All right, now let's talk about Venn diagrams proper. To motivate that, I have an example here where we're giving a survey to 50 people. We're going to assume all 50 actually respond to the survey. And we ask them, what source do you primarily get your news from? So the options that they are given are social media, TV, none, or both. So to be clear, social media can include anything from Twitter, Facebook, Instagram, TikTok, TV, anything that's broadcast publicly or by cable. None means that neither of these broad categories of sources are what they use to get their news from, or they use a combination of both. So what we're collecting here is categorical data, and the way that we can think about this particular survey is maybe we have information about how many pick each one of these choices. So first, we know that 22 people select social media. 13 of them choose social media only. So to distinguish what's happening here, between the 22 and the 13, the 22 select social media, but they also could have selected both. So it's possible that they said social media and TV. 34 people choose TV. And again, that could be both. It doesn't mean TV only. Our experiment for this scenario is to randomly select a response. So what we're essentially going to be doing is we're going to be thinking about the random selection from a voluntary response sample. And this random selection will help us to build intuition about what's likely and what's not. So first of all, how do we design a Venn diagram? You've probably used them before in the past, but the way we're going to be using them here is a little bit more precise. First, we pick our events of interest. So I've selected A and B, which is A is the event in which the randomly selected person has chosen social media, and B is the one in which they choose TV. So this has secondary sets that we can build from it. So first of all, the intersection of A and B is the event in which they select both social media and TV. A union B is the option in which either one is selected, so TV or social media, or possibly both, right? So mathematical or it's not exclusive. And then we have two more, which are the complement of A bar, is the event in which this person did not choose social media. So we know nothing else. We just know they did not pick social media. And B bar, or complement of B, is them not choosing TV. Okay. With that, the second step is to draw a box for the sample space. So our box here, this is our box. And each event A and B gets a circle. So I have my A circle, and I've got my B circle. And what this does is it actually helps us determine the individual pieces of these sets that we've discussed in the previous parts, which is we have the only A section, which is this like crescent shape part. A intersect B is the overlap. Only B is this crescent, blue crescent here. We also have the interestingly important part, which is neither A nor B, and that's everything that's outside of the two circles. And we know that our sample size, or the size of S, is 50. In each space, we're going to write our cardinalities. And we know we've done it correctly if we satisfy three conditions. So first, the sum of all these individual cardinalities or sizes of the sets is equal to S. We also should check that only A, the number of elements in only A, plus the number of elements in the overlap is equal to the number of elements in A. And similarly, that the number of elements in only B plus the number of elements in the overlap is equal to the number of elements in B. So two sides of the same coin there, which is have we actually disaggregated everything properly. And the cool thing about this is that this all comes from the fact that only A intersect B, only B, and neither A nor B are actually a partition for S. So we've accounted for everything if we've selected these groups. Okay, so let's go back to our example. Let's put it all together. So what do we know first? So we know our sample space has 50 elements in it. We know that the number of elements in only A is 13. We know that because that was given to us. We said, let's go back real quick. 13 choose social media only. That's telling us about how many people are in only A. So that goes in this magenta crescent circle. We know that 22 select A in total. So 22 said that they get their information from social media. And that tells us then something about the overlap, which is that the number of elements in A intersect B has to be 22 minus 13. So the difference, because they need to add up to 22. And that's going to be 9. And now that tells us something about only B, because, remember, we know that 34 people choose TV. But we've already accounted for the overlap, that's 9. So we take 34 minus 9, that gives us 25. And in the complement of all these three parts, so the neither A nor B set, we're going to take 50 and subtract 47 from that, because 47 is the sum total of all these categories here. And that gives us 3. So only A, 13 people. Overlap, 9. Only B, 25. And neither will be 3. So now we can make we can determine some probabilities of these different events. So first question, let's find the probability that a randomly selected response is TV only. In other words, probabilistically, what we're saying is we're trying to find the probability of the only B set. So if we can find the number of elements in only B, take that as a proportion of the number of total elements, that gives us the probability. So that's 25 out of 50, which it gives us 1/2. Second question, find the probability of either social media or TV. So here's the trick though. So the probability of A union B is never equal to the probability of A plus probability of B unless we have disjoint events. We're going to get into that in a future video, but the idea then is we need to actually calculate this directly. So the proportion of elements in the union of A and B divided by the number of total elements. And we can just take our 3 pieces that we were working with in the partition. So only A, only B, and A intersect B. So that gives us 13, 25, 9 over 50. Add that all together, we get 47 over 50, or 0.9